In this video tutorial, we will be discussing on designing the perfect qPCR experiment to help you to conduct gene expression work. So when it comes to designing qPCR primer pairs, there are some basic features that you should look out for to create a good quality primer pairs for gene expression. The first one is designing an amplicon that are between 70 to 200 base pairs. Amplicon or fragment size which are more than 200 base pair are generally not recommended. Anything larger than this is likely to have a low primer efficiency, or you can say that the shorter sequences can actually amplify with higher efficiency. So overall, you should not create something too small or something too large. Just design an amplicon of about 150 base pair or around from the exonic region. The next feature of a good primer pair is the primer length, and it should be between 18 and 22 base pairs long. And so again, do not design the primers which are either too short or which are too long. Just design the primer pairs that are of around 20 base pairs. The next feature of a good primer pair is the melting temperature of the primers. The melting temperature should be between 56 to 63, but ideally it should be around 61 or 62 degree. So what is the melting temperature of a primer? Melting temperature is when half of the primer has become dissociated and becomes single stranded. Another thing is the melting temperature of both primers should roughly be the same. For example, if forward primer has a melting temperature of around 62, then the reverse primer should also have a melting temperature of around 61 or 63. And remember that the annealing temperature of a primer is always 1 to 3 degrees centigrade less than that of a melting temperature. If the melting temperature of a primer is 63 degree, then its annealing temperature would be around 60. The next feature of a good primer pair is the GC contents of the primer. The GC content should be in range between 40 to 60%. Again, both the forward and reverse primers should have roughly the same percentage of GC. As in this example, forward and reverse primers are having 55% of GC contents. So, why is the GC contents are important? The answer to this question is that if a primer is having higher amount of G and C contents, then its melting temperature would be higher. If the melting temperature is higher, then definitely the annealing temperature would also be higher. This is because there are three hydrogen bonds between G and C and only two hydrogen bonds between A and T. The next thing you should consider is to avoid sequences with long repeats. Anything more than 4 is not recommended. Another aspect of a good qPCR primer is what is known as having a GC clamp. As we mentioned earlier, that a GC binding is stronger than AT binding, so a GC clamp is when you have at least one G or C base in the last 5 bases of your primer. For an example, this is a sequence of a primer, and if you look at the last 5 bases, we can see that this primer does contain a GC clamp because there is a G and as well as C in the last 5 bases. The reason why a GC clamp is useful is that it ensures that the primers binds completely onto the template. The most important feature of a good primer pair is that the primer pairs should be separated by at least one intron, or you can say that the primer must span exon-exon junction. For example, we have a gene here. It is having 4 exons and obviously it is having 3 introns. By exon-exon junction, I mean the forward primer should be designed from one exon and the reverse primer should be designed from another exon, preferably from the last 2 exons, because the cDNA synthesis starts from this end. So at the end, check the specificity of your primer by doing the primer blast. So that's it. It is all about the designing of a good quality qPCR primer.